Hello and welcome back to this next part of Chapter 2. Today we'll be looking at distributions from data and how we create that. So specifically we'll be looking at frequency distribution, relative frequency and percent frequency distribution for quantitative data, and then looking at graphics, histograms, and then cumulative distributions. Fairly easy things to do. You just have to think about what you're doing. So one of the first things we'll look at is a frequency distribution, and specifically towards categorical data. So this would be data that's not numbers. So it's like how many times did something occur out of this entire data set that we're collecting. Okay, and so if you look here on the screen, it's a summary. The frequency distribution is a summary of data in several non-overlapping classes. The classes might be referred to as bins. Survey data that I've done might be looking at, okay, how many people were in the age range from 0 to 15, 16 to 25, and so on. So you get what a bin is, or a non-overlapping class. All you're doing is counting up how many of an item either fits in a bin or is of the same name or category. So let's go ahead and look at an example. So in your book, you have this data set called soft drinks. And so it's like, okay, here are the last 50 soft drink purchases. What's the distribution of this data? So what's the frequency? So this is the purchase of the one of 5 popular soft drinks, which one had the most sales, and so on. So when you add them all up and you look, you can see that Coca-Cola had 19, Diet Coke had 8, and so on. Right? So Coca-Cola is the leader, Pepsi's second, then Diet Coke, and then Sprite and Dr. Pepper are tied for 4th. So you see Dr. Pepper here and then Sprite with both just a frequency of 5. So this can be kind of time consuming. So how do you do this inside of a spreadsheet? Well, there's a specific type of function called COUNTIF that will go in there and count the number of matches based on the correct spelling in your data. So it counts the number of times a certain value appears in the range that you're looking at. So I've opened up that spreadsheet. You see it on the screen here. I'm actually going to do something a little different just to show you what it does. So we've got bins here. That's what was in your book. You'll see that. Our bins are going to be the unique names of soft drinks over here. And then I'm going to do sample, spell it exactly the same way as it's spelled here, because that becomes a field name. So I'm going to highlight all my data. Then I'm going to click Data tab, Advanced Filter, the criterion range. I'm going to set as this field name and blank underneath, so that means it's going to be all data. And I want to do unique records, and I want to copy to another location, and that location is going to start right there. And I should get the output of each one, the unique values that it finds inside of that. So yeah, I could have just typed it in like they did in the book. But if you had thousands and thousands of rows and you wanted to know, okay, how many unique items do I have, you would use this advanced filter technique like I just showed you to get those unique names. So now we can do something like the book is doing. I'm just going to get rid of this, and literally I'll just copy this up here just like it has in the book. I think it's in column D. So Control C, 50. And then our unique values are these. Control C. And we're going to put that right underneath. And want to do a merge, so run into some problems. I'll do format cells, alignment. There's no merge here, so I'm not sure. Keeping track of this one. So I got to unmerge that one. Now I can do Control C, Control V, just so it doesn't confuse you from what's written in the book. I'll delete it all. So now we can use those count if functions. So we'll say equals count if, and the range that we want to look in is this range. And that's going to be the same for everything. So I'm going to hit F4. That makes it absolute on both sides. Absolute on the beginning cell address, absolute on the ending cell address for our range, comma. The criteria is going to be this cell here. So hopefully you can see what that formula looks like. The reason I press enter already, it's already showing up on the screen. I'm going to press control and the little accent key to turn formula viewing off, and so you can see here's the formula and here's the value. I'm going to hit Control C, I'm going to copy it down, and you see it gives me the values that we're looking for. Probably not in the same order that you have in your book, but it gives me the same frequencies for all of the values that are over here. The next thing we want to talk about is relative frequency and percent frequency distribution. So relative frequency is the tabular summary of data showing the relative frequency for each bin. The percent frequency distribution then summarizes that frequency of the data for each bin in percent terms. So this is when you have percent frequency, it provides an estimate of the relatively likelihoods of different values of random variables. So what should be in that bin? And remember, the bin was a range. So we want to calculate something like this. And the only way we're going to calculate something like this is if we get the total number of items, or N, or sample size, that we collected. And so that'll give us this relative frequency, and then we'll get our percent frequency. Right. So I'm going to just do this real quick for you. Relative frequency and percent frequency. We'll widen up this column a little. You should practice doing this. So let's see, we need to get a total here, so I'll hit this summation button. Yeah, that's the range, 50. So equals this value divided by this value. I'm going to press F4 because I want it to be fixed every time. Now I can copy that down. And to get percent, I just multiply by 100. So I really want to do is just move this decimal point over 2. So it's equals this times 100. Control C. Copy it down, and we can see that we got now our percent frequency. Fairly easy thing to do. So basically, to get your bins, the frequency is how many times did something occur in your data set. Count all those up. Here we use the COUNTIF function. Get a total number of items in your data set, which was 50. divide that into each one of them. That gives my relative frequency. I could spell here. And then we just multiply that by 100 to get our percent frequency. The next thing we want to talk about is distributions of data for quantitative data. So there's three things you got to do, or three steps. First, determine the number of non-overlapping bins that you're going to have. Determine how large those bins are going to be. So quantitative data. So that might be age. So you might have 5 bins of ages. So you could actually compare the ages from one group to the ages to another group. Right? And then determine the bin limits. So that's the approximate bin width. Then is your largest data value minus your smallest data value divided by the number of bins. Right? So that's telling you how big things should be when based on the data that you've got. Okay. So again, bins are formed by looking at the ranges that are used to group your data. You typically would have somewhere between 5 and 20 bins. Small numbers of data items, you might only have 5 or 6 bins. If you have a lot of data, then you're going to need more bins, right? So the idea is that you have enough bins or ranges to show variation in your data, but not so many bins or ranges that you only have a few items in each bin. Then it doesn't become a very good comparison. So let's look at an example. So here we have some quantitative data, and it's the number of days for a year-end audit. Right? So maybe we have different auditors. How long is it taking them to run their year-end audits in days? And we collect that information. So we count up how many items are we looking at. Here are N, number of observations. 5 times 4 is 20. So we choose to develop a frequency distribution with about 5 bins. All right. So the largest value is 33, and the smallest value is 12. So because we're going to summarize our data with 5 classes, or 5 bins, then we take our 33 minus 12 divided by 5 equals 4.2. So because that's over 4, we then round up and use a bin width of 5 days. So we started our smallest, go from 12 to 17. So that's how that 17 was determined, if we were going to divide it that way. So just keep in mind that these data values is the largest data item in your set and the smallest item in your set. And so then you need to determine, okay, do I want a large number of bins or a small number of bins? Well, if you have not that many items, like N of 20, that's small, so that you're going to keep that small. So maybe 5 or 6 here. And so it's just something that you have to work with your data. Now, in this particular example, the author chose to not start at the lower limit in the data, but actually start at 10 and go to 14. But the 14 is the 4 days that we came up by doing that calculation. And so that way, our 33 falls in a bin of 30 to 34. So again, you would have to look at it and play with it to see it. And so an example then becomes, okay, we've got our bins, audit times and days. So 10 to 14 days, 15 to 19 days, and so on. Then we count up how many fall in that bin range, if you would. So there were 4 in the 10 to 14 days and 8 in the 15 to 19, and so on. Then we get the relative frequency and the percent frequency. Again, that's done by getting the total number here, divide that total number into each one of these frequency values, multiply by 100 to get this over here, and it should add up to 100%. If it doesn't, you've done something wrong. So the next thing I want to show you is how to do this inside a spreadsheet. So we follow along with what the book has. We know that we're going to create our bins here, and we're going to get our frequency here. Okay. So our bin, we just need to put the ends of our bin number. And so we got it's actually going to go 0 to 14, then 15 to 19, and then 20 to 24, and then 25 to 29, and then our last bin is going to be 34. So we're actually going to use a formula, or function I should say, called frequency. So we're going to say equals frequency. I'm going to hit tab and I can spell it out. So the first thing we need to specify is the data array. So the data array is going to be this one that contains all the data. And then our bin area is going to be, for me it's going to be A9 to A13 because I didn't type it in the same way as you did in the cells. Close parentheses. And now, since this is an array function, you've got to enter it. You can't just hit enter. You got to hit Control Shift and then enter. All right, so that works that way. So for that bin, there were 4 in there. And I believe I showed you how to do this wrong. So let me just back up for a second. Because it is an array type function, we needed to do, you need to highlight this, the bin range, and now type the formula. So hold on a second. Got to highlight the array where you want the output. Then you start typing equals frequency. We highlight the data range, comma. Then we highlight the bin range, close parentheses, Control Shift Enter. And if we do it right, it'll fill the entire bin. This is, to me, this is something you just need to practice with. As you can see, I don't do this very often. I do it once a semester when I'm doing final grades and I want to know what is the frequency of my A's, B's, C's, and D's and F's. And so my bins would go to, say, 59, then from 59 to 69, and so on. And so you could see how you could just use that in order to get your frequency of your grades rather quickly. But again, go back and practice doing that. Make sure you can do it. So we would highlight this, highlight an array area. And the array area needs to be the same size as your bin area. Then as that's highlighted, you start typing your function, especially this array function. You provide the ranges that it needs. Notice that we don't need to make anything absolute. We close it, then Control Shift Enter. And so again, you see I got the same distribution. And as you practice doing this, you should get output like you see on the screen. So I'll be sure and give you some homework problems that'll have you calculate this frequency distribution for quantitative data. So we looked at quantitative and what I would call categorical or qualitative data. Then you know how to do those frequency distributions now. I'm going to pause now, and when we come back, we'll start on creating histograms.